Good morning, mighty mathematicians of the Congo Nation. I'm Sister Johnson, and welcome to our math lesson. Today is Thursday, April 23rd, 2020. I have a recognition. I would like to recognize all of the scholars who submitted their math assignments. We had each scholar receive 100% on their fluency assignment. So you are doing so excellent with your addition and subtraction. Please keep up the good work.
The need for today's lesson is to find and name three-dimensional shapes. But let's begin with our application problem. Please write your application problem in your composition book, and let's read it together. Moja and Billy tattoo. Brother Rayvon draws 4 triangles. Brother Shaquan draws 7 triangles. How many more triangles did Shaquan draw than Rayvon? Wonderful reading, scholars. Now finish copying down your application problem and resume this video.
Okay, Congo Nation, let's reread our word problem for fluency. Moja and Billy tattoo. Application problem. Brother Rayvon draws 4 triangles. Brother Shaquan draws 7 triangles. How many more triangles did Shaquan draw than Rayvon? All right, Congo, I'm going to grab my marker. And this problem is a little different than problems we've done in the past. We are going to compare the amount of triangles that Brother Rayvon has with what Brother Shaquan has. All right, so we're going to do a model that's a little different from what you've seen before. But first, let's annotate our word problem. The first step of our cube strategy is our C. What does that mean, Congo Nation? Very good. Even though I'm doing something different today, I can still circle my key numbers. So what's the first key number that you see? Good job, Brother Charles. It's 4. So I'm going to circle 4. What's our next key number? Thank you, Sister Jador. Our next key number is 7. Very good. Congo Nation, do you see any more key numbers? Yes or no? No, we don't have any more key numbers. So we can move on to the next step of annotating our word problem. We are going to underline our question. I want everyone to point to their question mark in their application problem. And once you point there, say check. All right, very good. So we know that our question mark is here. So that means that this is our question. I'm going to start here at my question word, how, and underline the question. How many more triangles did Shaquan draw than Rayvon? So since we are comparing Brother Rayvon's triangles with Brother Shaquan's triangles, I suggest that we draw 2 tapes with the same endpoint on the left so that we can more easily compare those 2 numbers. Gave up? All right, let's get started. Congo, I have a question. How many triangles did Brother Rayvon draw? Show me with your math fingers. Very good. He drew 4. So we're going to start off by drawing Rayvon's 4 triangles, and then we will turn it into a tape. Yay, Bo? All right, so let's draw his 4 triangles. Moja and Billy tattoo. 1, 2, 3, 4. Great job. All right, in order for me to turn this into a tape, I have to put a rectangle around my triangles. Yay, Bo? So go ahead and put a rectangle around your triangles. And now we have a tape showing us how many triangles Rayvon has. But with this picture, can we tell that these are Rayvon's triangles? We know that they are because we know that he has 4, but I think that we should add a label. I think we should put an R here so that we know that these triangles belong to Rayvon. Yay, Bo? All right, I have a question. How many triangles did Brother Shaquan draw? Show me with your math fingers. 7, very good. So just like we did with Rayvon, we're going to do a tape for Brother Shaquan. Let's begin by drawing Brother Shaquan's triangles. 1, and I'm going to pause there. Remember we said we want the endpoints to be the same, okay? So we are going to make sure that as we are drawing Brother Shaquan's triangles, that they're lining up with Brother Rayvon's so that we can compare them more easily. Yay, Bo? All right, 1, 2, 3, 4, 5, 6, 7. Very good, Congo Nation. Let's turn it into a tape by drawing a rectangle around it. And what should be my next step? Very good. I'm going to label this tape with an S for Brother Shaquan. Yay, Bo? If you're with me so far, say I'm with you. All right, very good. Now that we have this model, it's much easier for us to compare. Let's revisit our question. What does our question say? What are we trying to solve? Let's read it together. Moja and Billy said 2. How many more triangles did Shaquan draw than Rayvon? Okay, so I want to know, what is the difference? What is the difference between Brother Rayvon and Brother Shaquan's triangles? Take a look at your model, and I want you to solve. What do you think? What is the difference between Brother Rayvon and Brother Shaquan's triangles? How many more triangles does Brother Shaquan have? Show me with your math fingers. Very good. If you said 3, you are correct. We can go here where Brother Rayvon's triangles end and Brother Shaquan's triangles continue. Right? Brother Rayvon's 4 triangles line up with Brother Shaquan's 4 triangles here. And then we see that the difference is these 3 triangles. Yay, Bo? So 3 is our answer, but let's double check by making a number sentence. If I'm finding the difference, what operation am I going to use to solve? Subtraction, very good. We can do subtraction to find our difference. So we know when we do subtraction, we have to start with the largest number. We always take away from that larger number, yay, Bo? Which number is larger, 7 or 4? 7, very good. So 7 is going to begin my subtraction number sentence. So I'm going to write 7 here. What symbol do we use when we do subtraction, Congo? Good, we use a minus symbol. So I'm going to draw my minus symbol. 7 minus. All right, what's next? What's my known part? 4, very good. I know how many Brother Rayvon has, and I know I'm looking for the difference. So I'm going to subtract 4 from 7. Let's get our answer by counting back. So we want to put this whole number 7 in our head. And we're going to count back to the number 4. See how many are on our fingers. Yay, Bo? All right, Moja and Billy Tattoo. 7, 6, 5, 4. Congo, did we get 3? Yes, we did. So that means that our model is correct. The difference between Brother Rayvon and Brother Shaquan's triangles is 3 triangles. Okay? So how many more triangles did Shaquan draw than Rayvon? Give me a complete sentence, please. Very good. Shaquan drew 3 more triangles than Rayvon. Let's write our statement up on the board. You guys did excellent work. I'm going to write it here. Shaquan drew 3 more triangles. Triangles. Can you guys see that? Move my flowers over. Triangles. Then, which is a comparing word, Rayvon. Good job. Clap it up for yourselves. Good job. We are finished our application problem. Let's move on to the next part of our lesson. The next part of our math lesson is your fluency assignment. Please pause this video and take a few minutes to complete these 10 subtraction and addition problems. Once you're finished, please resume the video. All right, scholars, thank you for completing your fluency assignment. Now let's begin our concept. Our concept today is to find and name 3-dimensional shapes. Before we begin, I want to give you one of our vocabulary words. Our first vocabulary word is face. Face is each flat surface on a 3-dimensional solid. Each flat surface on a 3-dimensional solid. Let's go ahead and look at an example of a 3-dimensional. I want you to be a mighty note taker and copy this web chart down in your composition book. Our topic is 3-dimensional shapes, and we're going to talk about what that means. We're going to use this 3-dimensional shape as an example. So please take a minute, pause this video, and copy this web chart down into your composition book. All right, scholars, so what do you notice about this object? What shape is this object, Congo Nation? Okay, it resembles a rectangle, right? It has 4 straight sides, but they aren't of the same length. Is this box or object flat? No, very good. This is a solid object, okay, Bo? So those are 2 things that we can add to our web chart. One attribute about a 3-dimensional shape is that it is not flat. So I'm going to write that here. 3-dimensional shapes are not flat. Okay, Bo? All right, Kygo, and if it isn't flat, that means that it is a solid. So we can add that to our web chart as well. 3-dimensional shapes are solid. Now, Congo, if I had a flat rectangle in my hand, would I be able to do this? What do you think? Yes or no? No, very good. I would not be able to do that. What I just did was touch each flat surface on this 3-dimensional shape. Okay? What do we call each flat surface on the 3-dimensional shape? Very good. We call it a face, or a vocabulary word. So what's true about 3-dimensional shapes is that they have different faces. Yay, Bo? So I'll write that here. 3-dimensional shapes have different faces. Okay? And we can also also write that you can touch them, right? We can touch them on different sides of the three-dimensional shape. So three-dimensional shapes, and we'll have to write a sentence. We can touch the faces. All right, Congo. So let's read over our web chart before we continue, all right? So these are the attributes about a three-dimensional shape. Three-dimensional shapes are not flat. Three-dimensional shapes are solid. Three-dimensional shapes have different faces, and we can touch those faces. If you with me, say check. All right, if you need to pause this video to complete your web chart, you may. We're going to move on to the rest of our concept development. Mighty Mathematicians, there are three-dimensional shapes all around us. I have gathered some examples that are in my home. Yay, Bo? And later on, you'll have an opportunity to go around your home and go on a hunt of three-dimensional shapes. But let's take a look at each one and learn their names. We're going to start off with this box of tissue. Yay, Bo? All right, so we learned what face means. All right. This box of tissue has different faces, right? It has a side here. It has a flat surface here. It has a flat surface in the back, at the bottom, on this side. Yay, Bo? So we know that that alone makes it a three-dimensional shape. Is it flat? No, it isn't. So we know that, that fits with our web chart and what we learned about three-dimensional shapes. Yay, Bo? And I can also touch it on different surfaces, okay? So what does this look like to you, Congo? Who knows the name of this three-dimensional shape? Very good. If you said cube, you are correct. Yay, Bo? Cube is a three-dimensional shape with 6 square faces. Yay, Bo? It has 6 square faces, and we're going to double check. So first, I have a question. Does this face look like a square? Yes or no? Yes, it does. So we know that each face is shaped like a square. Now let's check to see if there are 6 of them. Yay, Bo? All right, so I'm going to stick this cube here. I'm going to grab my Post-its that are numbered 1 through 6. And we're going to see if each of these surfaces adds up to 6 of them, just like our definition tells us. Yay, Bo? All right. So let's count these faces of this cube together. Let's make sure that it's a cube. All right, I'm going to take this Post-it that has the number 1. All right, so that's the first face. 2. 3. 4. 5. And 6. Okay, and let's make sure that we cover each face of this shape. Yes or no? Yes, we did. Very good. So, does it match with our definition? Is a cube a three-dimensional shape with 6 square faces? Yes, it is. Very good. So now we know that a tissue box is an example of a cube. Everyone say cube. Good. What's another example of a cube? Okay, very good. So I heard dice. Good. Those are great ideas. Yes, those are examples of cubes. Yay, Bo? All right, let's sit our cube there. Now, let's go and move on to another shape. And actually, before we move on to another shape, I have another vocabulary word that I want to teach you. Because just like we learned on Tuesday about shapes, regular shapes, flat shapes having sides And corners, three-dimensional shapes have corners as well, but we call them something else. We call the corners of three-dimensional shapes vertices. Okay, one corner would be called a vertex, but more than one corner is called a vertices. So vertices are corners or points on a three-dimensional solid. Okay, Bo? So those are the corners or points. Let's take a look at our cube. This would be a point. There's a point here, a point here, a point here, as well as points at the bottom of this three-dimensional shape. Okay, Bo? So those are our vertices. All right, moving on to another shape. Got this basketball here. Looking at this basketball, what shape is it? Very good, it's a circle, okay? And this circle, now that is a three-dimensional shape, is called a sphere. You say sphere? Say it one more time. Very good. A sphere is a three-dimensional shape with no flat surfaces. Is this flat? No, right? This ball is round. Okay, so a sphere does not have any flat surfaces. It is a round three-dimensional shape. What are some other examples of spheres? Okay, yes, of course, a baseball. Would a football be a sphere? No, very good, very good. It's not in the shape of a circle. It's not round, Abo. Okay, very good, Congo. So this is called a sphere, a three-dimensional shape with no flat surfaces. Very good. Moving right along, let's take a look at our next three-dimensional shape. Scholars, this is a rectangular prism. Yabo, rectangular prism. A rectangular prism is a three-dimensional shape with 6 rectangle faces. Yabo, a three-dimensional shape with 6 rectangle faces. So let's check. Let's take a look at our rectangular prism. What shape is this face of the rectangular prism? Is it a rectangle? Yes or no? Yes, it is. Very good. What about this face? Yes, it's also a rectangle. Very good. What about this face? Rectangle. Is this a rectangle? Yes, so even the smaller sides of our rectangular prism are in the shape of a rectangle. According to our definition, this should also have 6 faces, just like our cube. All right, Congo, so does this rectangular prism have 6 faces? Let's count and see. This first face, we'll put a 1. 1. 2. 3. 4. 5. And 6. Uh-oh. Very good. So we know that this is the 6th face on this rectangular prism. All right, so the attributes of a rectangular prism is that it has 6 faces that are in the shape of a rectangle. Yay, Bo? All right, moving right along to our next shape. Our next shape is a cylinder. This is an example of a cylinder. Yay, Bo? A cylinder is a three-dimensional shape with 2 circle or oval faces that are the same size. A three-dimensional shape
with two circle or oval faces that are the same size. Let's take a look at this cylinder. According to our definition, this shape should have either two circle or two oval faces that are the same size. So we know that this here is not a flat surface. So that means that these are not our faces. However, is this a flat surface? Yes or no? Yes, it is. If I can lay my hand flat on top, that means it is a flat surface, okay? And I'm laying my hand flat on top. This is our first flat surface. What shape is that flat surface, Congo? Good. It's a circle. Very good. So far the attributes match our definition. Let's go to this side of this cylinder. Is this side flat? Yes, it is. What shape is this face? Great, is a circle. And we know that these two faces here are the same size. So that is what makes this a cylinder. Yay, Bo? Very good. All right, we've come to our last three-dimensional shape, which is a cone. A cone. Yay, Bo? A cone is a three-dimensional shape with only one circle or oval face and one point. Okay? It is a three-dimensional shape with only one circle or oval face and one point. So let's see if this fits that description. Is this a flat surface? Yes, and it looks like it's the only flat surface that I have on this cone. What shape is the flat surface? Very good, it's a circle. All right, so we have our one flat surface in the shape of a circle. Sometimes it could be in the shape of an oval. But it also says that it should have a point. Do you see a point on this cone? Yes, very good. It's right here. Yay, Bo? So since the shape has one flat surface that is in the shape of a circle, and it has this point, that's why this is a cone. Yay, Bo? All right, scholars, very good. So we learned 5 three-dimensional shapes today. We learned a cube, a sphere, a rectangular prism, a cylinder, and a cone. Yay, Bo? All right, now we are done our concept development, so we can move on to completing our problem set. Scholars, please begin by heading your paper with your first and last name, the date 4/23/20, the subject math, and your heading is problem set. For number 1 of your problem set, you are going to create this chart. Please turn your book sideways, and you're going to make 5 columns. In each of the columns, you're going to write the name of a three-dimensional shape. Your first column should say cubes. Your second column is for spheres. Your third column, cones. Your fourth column, rectangular prisms. And your fifth column, please write cylinders. Pause this video to complete your chart. Scholars, now that you have prepared your chart, I am going to show you pictures of objects, and you will write the name of those objects in the correct column according to their three-dimensional shape. At any time, please feel free to pause the video. Let's begin. Your first object is dice. What three-dimensional shape is this dice? Is it a sphere, a cylinder, a cube, a rectangular prism, a cone? Please write it in the correct column. Your next object is a can of paint. want you to visualize a can of paint around your home. Take a look at that can of paint. What three-dimensional shape is it? Write the name in the correct column. Your next object is a juice box. What three-dimensional shape is this, Congo? Very good. Go ahead and write it down on your problem set. Your next object is a block. This is one of O'Shea's favorite toys to play with. What shape is this block? Very good. So far, so good. I see some amazing work being done. Our next object is a party hat. Visualize that party hat on top of your head. What shape is that party hat, Congo? All right, next up is a globe. What shape is a globe? Please write it in its correct column. Next up is a baseball. What shape is this baseball? Look at its attributes. Very good. And then last up to be written on your chart is a box of tissues. Take a look at that face on this box of tissue. What shape is that? Write box of tissues in its correct column. All right, excellent work, Congo Nation. Now let's finish up our problem set. Scholars, for number 2 and 3 of your problem set, I want you to take a look at each picture, read the sentence, and then write true or false. So please number your problem set, number 2 and number 3. For number 2, you have a can of soda. The sentence says, this can is a cylinder. If you say yes, this can is a cylinder, please write true next to number 2. If you say false, this can is not a cylinder, please write false. For number 3, you have a juice box. The sentence says, the juice box is a cube. If you say yes, this juice box is a cube, please write true for number 3. If you say false, this juice box is not a cube, please write false. Congo Nation, thank you for completing your problem set. For your liberation work, you are going to recreate your chart and go on a house hunt for three-dimensional shapes. Walk around your home and try to find as many three-dimensional shapes as you can. Write the names of those objects in its correct column. Once you're finished, you are going to take a picture of your liberation work, your problem set, and your fluency assignment and send it to grade 1 at sfacs.us. Mighty Mathematicians, we have come to the end of our lesson. Thank you so much for tuning in and doing this great work with me. I will see you in just a bit in our science lesson.